Deforestation of the endemic Mabi rainforest in the Australian wet tropics has drastically impacted the richness and abundance of native rainforest species. With only 4.5% of Mabi rainforest remaining, organizations in the Atherton Tablelands like TREAT and the Queensland Parks and Wildlife Service have made recent strides to revegetate Mabi rainforest.
Since 1997, staff and students of the Center for Rainforest Studies at the School for Field Studies have been involved in restoration projects on the Atherton Tablelands. Restoration projects usually community-based or governmental driven. In 2022, the staff of the Center for Rainforest Study was approached by landowners to assist them in the restoration of Mabi rainforest on a cinder cone. You see behind me a cinder cone that is situated on their property. And our school was very excited about this opportunity because this opportunity gives us a chance to do intensive research on Mabi restoration on a cinder cone. And now we take up this opportunity and start the first restoration on a cinder cone.
Cinder cones are geological structures formed from extrusive volcanic activity, resulting in hill formations rich with basaltic soils. Basaltic soils are a notable characteristic of the Mabi biome, and prior to historic deforestation, Atherton Tableland cinder cones were once covered with Mabi forest. However, reforestation efforts on these volcanoes have not been explored and are quite challenging given their steep slope, which introduces issues with soil water retention and site maintenance. Researching ways to maintain soil moisture in a natural way led us to explore syntropic farming methods and opportunities to incorporate them into the restoration of cinder cones. We consulted Jane Hawes, a syntropic farmer in the Atherton Tablelands, on these topics.
Syntropic farming is a form of agroforestry that utilizes trees and a whole range of plants depending on the strata which is their light requirements, and so we get a great amount of diversity happening.
One of the 6 syntropic principles is to have no bare ground. Not only does covering the soil with mulch and plant debris serve as a natural fertilizer, it also contributes to overall water retention.
The slopes of cinder cone are prone to water runoff and solar radiation, reducing their ability to retain water, which is not good for newly planted seedlings. These challenges can be mitigated by increasing ground cover on the soil by using dead grasses, mulch, and cardboard. This physical barrier created by the soil cover slows down the flow of water over the soil surface, allowing more time for water to soak into the soil.
Another solution may be companion planting, in which fast-growing plants are planted to establish layers that aid plants who require more shade.
After talking with Jane, we found that banana plants would be ideal for moisture retention at the cinder cone.
Well, banana plants actually fill up, they're like a water sponge within their entire trunk. They're also huge through transpiration of water within a system, so we can use that then and they hold the water all around the area where they're sitting.
We decided to plant banana plants amongst the native saplings in 4 of our 8 plots, in an alternating pattern, to minimize bias from placement on the cinder cone. In order for future groups to determine the impact of incorporating syntropic principles, we took baseline assessments of seedling heights. Other baseline assessments include the composition and number of dung beetle species, ants, soil fungi and nematodes, soil nutrients, which included nitrogen, phosphorus, and potassium, and soil pH.
Put up against harsh conditions and unexpected barriers, we'd like to shout out everyone who contributed to this endeavor and made it successful. Thanks to the Queensland Parks and Wildlife Service and the SFS Australia staff and students for all of your support, tools, and assistance. We'd also like to thank the landowners who lent the cinder cone to us for reforestation. A special kudos to our advisor, Dr. Siggy Heiser-Pavlov, for being a font of knowledge and a driving force. And finally, thanks to Duncan for taking bold initiative in clearing the land for us and for testing the integrity of our electric fence. We hope that future research further contributes to Mabi restoration throughout the Atherton Tablelands.